Hello and welcome to the next episode of my compiler tutorial series. So in this episode we're going to be making the parser. In the last episode we'd finished making the lexer or the tokenizer. So you can see, we had this list of tokens, but how do we actually get that into some sort of format that represents the semantic meaning of our program? So when I say semantic meaning, what I mean is that our program can be defined as a list of high-level things. So one of those types of things is a structure, another type of thing is a procedure. And we want some way of storing this data in a way that's meaningful for our program. So for example, for a procedure, we want to actually get like the list of arguments and what types those are. We want to get a list of the statements in the body, and we want to store all of that stuff in some object like called a procedure object that has those values and then associate that with a name. So we're going to start off doing that now. So the first thing we're going to do is in the source directory we're going to make a new package. We're going to call this nodes. In this directory we're going to make a new interface which is just called node. Doesn't need any members. And then just to sort of get the ball rolling with the nodes thing, just to sort of show what I was talking about just a minute ago, we'll make two classes. So one is procedure implements, and they will both implement node. So this one implements node, another one, and they call this struct, and this will also implement node. Okay, if we go back to procedure, we now need to just define the list of members that this thing will have. So public string name, public list node inputs, public node output or return value, and then a public list of nodes, which is the statements. This will be put in your array list as well. So I'm just going to copy this line. In struct, similar thing, public string name, and a list of, not statements actually, we want to rename this. This will be body. Right, so this is the general idea, is that you just have a bunch of different classes that extend or implement node, and then you just make the fields of the types of things that you would like, and then later on you'll see sort of how we parse the list of tokens and then sort of fill out these members with the data that we need. So I'm going to go to the main class. So the type of parsing that we're going to be using is called recursive descent parsing. It's I would say probably the simplest way of parsing a program, because it's literally just calling functions to parse the different chunks of your code. That's literally it. Like, you just have an index of where you are in the list of tokens. You call a function to say from this point parse like a procedure, and then it returns you the procedure, and it's incremented the token index a certain number of tokens to the end of the procedure, so that you can then parse something else. That's basically it. And then there's just some look ahead type stuff. So you start at one token index and you say, oh, okay, there's like 5 different things that could be valid from here. So I'm just going to do some look ahead basically to work out which of the things it is, and then I'll call a function to parse it, or I'll sort of go into like a switch branch and I'll do the parsing for that type of thing there, and so on. So you'll see sort of as we go, but that's sort of at a high level, it's really quite simple. Just to help us sort of with the parsing thing, I'm going to make a small helper kind of object that's going to just keep track of the relevant data for our code, so the program text and the list of tokens, and also like an index of, the aforementioned index of where we are within the list of tokens. So we're going to make static class parser. This is going to have string program text, list of tokens. It's going to have a token index as well, and we're just going to make some helper functions. So token eats token, and this is just going to we're going to say while token index is less than tokens dot size, token current token equals tokens dot get token index plus plus. If current token dot type is white space, or is not white space, sorry, then return the current token. That's literally it, and then we just return null at the end. So yeah, all this does is it just sort of increments over the tokens token index until we encounter a token that's not white space, in which case we retrieve it and we return it. Sorry. So yeah, the reason for this obviously is that we don't want to be constantly hitting variable amounts of white space whenever we want to get the next token. We just want to say, okay, whatever the amount of white space is, however they've formatted their document, doesn't matter to us. We just want to get the next important token. So the other thing we're going to need is another helper function called token peak token, and it can have look ahead. I'm just going to say int peak index equals token index. Then sort of the same thing. So while peak index is less than tokens dot size, we're going to say token current token equals tokens dot get peak index plus plus. If current token dot type is white space, or is not white space, then so we also want another index, int found tokens is equal to 0, and then if it's not white space, we increment found tokens, and then we say if found tokens is equal to the look ahead, then return the current token. And the same thing, return null here. So this is just going to say, if we want to look ahead like 10 tokens, it will just kind of keep iterating over until it's encountered 10 non-white space tokens. Going to make a third small helper peak token again, or an overload, and this is just going to take no arguments and just going to return peak token of 1. And this is just sort of useful thing so that we don't have to keep typing look ahead 1 every single time. Okay, so we've done that. So let's, down here, after we print out our tokens, we're going to make an instance of that parser, sort of helper thing, parser, and then we're going to just assign the variables. So parser dot program text is program text, parser dot tokens equals tokens. Okay. So now we're going to actually start defining the procedures that will sort of parse our program. So first of all, we're going to have a list of token, and this is going to be parse program. Parser. Okay. This is just going to, at a top level, not list of tokens, sorry, list of node. So list of node, it's going to be list of node. We're going to import that from nodes. Right, so list of node, program, I guess. New array list, and then we're just going to return that program for now, just so that it doesn't give us an error. So in this, it's actually quite simple. We just say while parser.peak token is not equal to null. So actually, as long as we are in this, like once we exit this loop, right, we will return null. So in that case, the next token is, or the peak index has gone past the end of the list of tokens, so we're out of tokens, right? So while we still have tokens to parse, we will essentially parse a statement in here, parse statement. So I will sort of discuss what that means. And then, and then we'll add to this program and then we'll return. So the reason why I'm not just writing code in here is because parsing a statement is something that will happen like a lot. So we don't want to just duplicate the code. So we want to write this in its own function or procedure. So this is going to just return node parse statement. And we're going to pass in the parser for this as well. So in this, we're going to, first of all, we're just going to token start is equal to parser peak token. Okay, so first of all, what do I mean by a statement, I guess? So a statement can either be like a procedure, a structure declaration, it can be a variable declaration like this, or it could be some sort of expression, or it could actually be one of the sort of like keyword statements, so like if statements, while statements, that sort of thing. So yeah, there's a variety of things. It could be, we're just going to start off with sort of the obvious ones. So we're just going to do some cases for what the, like, depending on what the first and sort of second, third tokens are, it will determine what type of thing it is, and then we can parse it as such. So first of all, there's a lot of cases in which there's an identifier first. So this is constants and variables. So we'll do that first. So we'll say peak first token, and then if start is an identifier, right, then we've got one sort of branch. Otherwise, if start.type is a keyword, then we've got some other sort of, some other branch. And then otherwise, we're probably parsing some sort of expression that we don't really understand that well. Okay, so in the case where it's an identifier, we sort of, in this case, it could also be an expression as well. So by expression, I just mean like some sort of, one function call plus another function call, or one variable plus another, or something like that. Once we know it's an identifier, we want to get the next token. So we want to say next equals parser.peak token 2 to get the second token. And then we want to switch on this. So if next.type is equal to colon, then it's some sort of declaration. Okay. If it's a identifier followed by something that isn't a colon, then it's some sort of expression. Okay. Once we know that it's some sort of declaration, we can actually sort of consume those first two tokens. So we can say token name is equal to parser.eToken, and then token, well, we don't really need to make a variable for it. We can just say parser.eToken, and that will eat the colon after the name. Once we know that it's name colon something, we then want to say, oh, okay, is it a variable declaration or is it a constant declaration? So constant declaration is two colons, variable declaration is a colon and then an equals, but there can also be a type in there. So you can have, optionally, you can have a type in there. if you don't declare it, then it's inferred, right? So so we go back here. Now we want to redefine next. So we say next equals parser peak token again. And we say if next dot type is equal to colon again, then we know it's some sort of constant, right? Constant declaration. So in which case we can eat that token, so parser eat token, right? And then we can say, okay, now what kind of constant is it? Is it either a struct, or is it a procedure, or is it some sort of thing that is wrong? So then next we do next equals parser dot peak token again. So we're just reassigning this local variable to the next thing as we eat the token, right, and then get it again. So say if next dot type is equal to like struct, or actually yeah, for the minute we can only have struct, so that's the only valid thing. If it's a struct, then we'll create a struct. If it's an open parenthesis, then it's a procedure, right? And then otherwise it's you know, we'll say we'll just so eventually we'll put in some more like rigorous and sort of useful error reporting. For the minute we're just basically gonna in fact actually we'll just make a very dumb you know, print error, I guess, string text, and this will literally just print the text and then exit with error code 1, right? So let's make this, and then this is quite just so that we know we have errors, and then we can break point on what thing it is, or we can so print error of you know, constant declaration must be either a struct or procedure, right? So yeah, okay. Okay, cool. So in the case where it's a struct, we can get the name. So actually another thing we want to do in our parser is just make another small sort of helper function. It's just going to return the string value of a token. So string get token value token, and we're just going to return program text dot substring token dot index token dot index plus token dot length, and then we can use that here. So after we've got the name, string name value, name string maybe, token, or is parser get token value of the name, right? So in here, let's make our struct. So struct new struct name is equal to name string, right? Then now we've got another sort of interesting thing. So the other thing we want to do actually is we want to say so after we've got the name, the only other thing to get for the structure is the body, which is a list of nodes, and the contents of that will be also not an expression but a statement. So before we sort of start, because the contents of a structure will be like variable declarations, right? So we at least want to get that working. So we're just going to do that now. So we're going to say in the case where it's not a colon, right? So this is constant declaration, but this I'll just get rid of that quickly. This branch will be like a variable declaration, right? So it's yeah. So in the case where it's not a colon, we want to first of all just check to see if there's a type there, because as I mentioned before, you know, or in this case, obviously there's x colon and then a type. So, and again, since we're going to be parsing types a lot, we're not going to, just return like we're not going to parse it in that branch. We're going to make a separate function. So parse type parser. Right. And yeah, so we're going to say token next is parser peak token. If next dot type is equal to identifier, then token identifier is equal to parser eat token. Right, and then if yeah, I think that's fine. So yeah, if, and then we want to okay, so now we actually want to just define something that stores the types. So we're going to call this like primitive type, I guess. So it's going to be in nodes again. It's going to implement node. Right, so and then enum class type, or not enum class, that's C++. Enum type, sorry, and it's going to be public enum type, and then you can just put in the rest of these things. So float int other primitives, and then we just do type like that, and this is public as well. Right. So in here now we're just going to sort of we're just going to switch, and depending on what type the thing is, then we'll, yeah. So we're going to say switch identifier. Actually, we want to get the text, so we want to do string identifier text is equal to parser dot get token value of identifier. It's not really an identifier, but switch this case and just put in the values. So float, it's gonna we're gonna say so we're gonna make a new type here actually. So or a not a type, but we're going to so we want to do primitive type dot type. Primitive type. Okay. Float primitive type is equal to. Actually, yeah. So actually, we'll do this slightly different. So we'll say primitive type equals the switch. Yeah. And then we don't need to define this each line. We can just say float case int case bool, right, like that. And then in the default case, if it matches none of those, we set it to null. Whoops. Yep. And then we just do a check here where we say if primitive type is equal to null. So if it was none of those, then we actually want to return a different type, which is going to be a struct type. So it's going to implement node and string name, public string name. So the way that this is going to work is this is just going to act as like a placeholder. So we're just going to say if it's some sort of string type that we don't know what that type is. For the parsing stage, we're just going to assume that it's some sort of user-defined structure that we don't know about yet. And then in the sort of type checking kind of, tree processing stage, we'll actually link that up to the correct structure if it's defined. So primitive type equals null. We're going to say struct type is equal to new struct type, and then struct type dot name is equal to the identifier text, and just return that. So return struct type like this. Okay, and then if that doesn't go through, then we just say primitive type, primitive maybe equals new primitive type like this, and then primitive dot type is primitive type. Okay. So I think that should work. And then otherwise we'll just print error. Not a valid type. Okay. So actually, no, this is fine. So we actually don't want to do that because there'll be cases, for example, like if it's an equals after, this branch won't trigger, and then we'll just return null, which is correct. So yes, so in here, we now want to say, well, first of all, actually, we want to make another node for the variable declaration. So variable declaration implements node. I've misspelled this. There we go. Right, so yeah, public string name and public node type. Okay, so we've got a variable declaration. Oh, and value as well. So public node value, and this is just going to be like a default value. So like in this case, for example, here we've got all three. So we've got the variable name, we've got the type, and also the value. And then obviously there's the case where you don't have the type, where it's inferred, and then there's also the case where you have like the name and the type, but you don't have the value, right? So that's sort of how that works. Go back to main here, and here we're going to say variable. Whoops, a daisy. I've got caps lock on. There we go. Variable declaration. In here we actually, so we've already eaten like the the colon and the thing. So we want to now say, okay, we've got the verdict, so we set the name on that, name string. Okay, I misspelled this again. No, that's fine. Okay, then we want to set the type. So we want to say var declaration.type is equal to parseType, parser. So that should do that, and if it's null, then that's also sort of valid, right? So it's a valid value. Right. I think what we'll do for the minute is we'll just leave out the case. So we'll just say return var declaration, right? For the minute. Eventually, what we'll need to do is actually put in the expression parsing, so that the value will be equal to like parse expression. So since we put that in, we also do want to make a just another small sort of procedure that's going to be for parsing blocks of statements. So list node parse block parser. And in this, we're going to say if, so we're going to say token next is equal to parser.pToken next, or if next.type is not equal to open brace, print error block must start with open brace. Right, so parser.eToken, right? Then it's sort of similar to the parsing the program, so you just say while parser.peak, peak token is not equal to close brace, so or .type, sorry, is not equal to close brace. Then we want to do sort of same thing where we just say, node statement is equal to parse statement, parser. And here we'll make our list of nodes, so list node block new array list, and then block.add statement. And at the end, we just want to do sort of the same thing. So if parser.peakToken.type is not equal to close brace. In fact, actually, this should. So this might actually loop forever, but so maybe we should probably put in something else. Or parser peak token. So actually, we want to put the null check in first. So I'm going to say while parser.peakToken is not equal to null, and I suppose or, yeah, so or parser peak token. Well, it actually has to be and, because you can't have a, yeah. So while it's not equal to null and it's not close brace, do this. And then we want to say if parser, so peak token like is equal to null, then we say block or print error block must end with a close brace, and otherwise we just eat the token. So tokenizer or parser dot eat token to eat that closing brace. We actually also in here we want to say once we've got the statement, we want to sort of parse the semicolon. So we want to say parser dot peak token or token next. We can maybe define it. So next is this. And we want to say if next dot type is equal to semicolon or is not equal to semicolon, then like we may have an issue basically. So otherwise we eat the token. So in the case of like semicolons, so there's some statements that do end with semicolons and some that don't. So for example, all these end with semicolons. However, like an if statement doesn't. You could make it so that it needed to, but it would be sort of redundant, right? Because you syntactically you know what the end is. It's not ambiguous. So I think probably the way that we so for the minute we're not going to deal with the if statements. So we'll come to that later. I think but we will need to fix that eventually. So if the next type is not semicolon, then we just print an error. So we said print error missing semicolon. Otherwise, we eat the semicolon and then we add to the list of statements. And then just down here returns, block like that. Okay, now in the struct thing, we can now do struct.body is equal to parse block parser like that. And so this won't, in fact, and then actually all we need to do is just return the struct. There's nothing else to do. Down here we'll just return null to keep this happy. And I think we should be good. So now what we should be able to do is if we only have a structure in our code, we should just be able to parse that correctly. So I think we'll just do that as a test. So we'll say list node program is equal to parse. One of these. So this one needs to be static. In fact, these all need to be static. Okay, so that's good. So done that, and now down here we can say parse program parser, and as long as we just sort of get rid of this stuff for now. I'm not sure, however you do it. If you just cut it in my case, or if you put it in a different file, it doesn't matter. Okay, so I'm just going to put print out here so I can put the debugger on the next line. So we're just going to run this and just sort of see what happens. No. Okay, so I think, so either we hit an infinite loop somewhere. Yeah, okay. So we've got some issue. Well, that would be it. So we haven't actually added the, so we'll say, just say program.add parse statement, parser. And since for the minute at least we know that these are all going to be like top level statements that don't have semicolons, we don't actually need to worry. But yeah, it's very like rough draft. We will fix that stuff later. Okay, block must start with an open brace. So I think, let's see. Right, so we just haven't we haven't eaten the struct keyword. So we'll try that again. Let's see what happens. Right, so we at least get through to the end now. And if we have a look at our program, we have array list size 1, struct name vector2 body, variable declaration x of type float, and y of type float. So I think that's a good sort of starting point. We've kind of shown that, sort of roughly speaking, how this parsing works. I think in the next episode we'll go through and we'll just sort of fill it out, and we'll cover expressions as well, which is kind of a meaty thing in of itself. But yeah, so thanks very much for watching, and hope to see you in the next episode, which we'll be doing the parsing the rest of it.